We'll start in 1 minute. We'll continue today reviewing for test 2. Test 2 is tomorrow morning at 8 o'clock. Later today, I'll send a link for the Zoom meeting for tomorrow. Okay, we got to number 9, solve the equations by factoring. This first one, n plus 9 times n minus 2 equals 0. So most of the work is already done since the right-hand side is 0 and the left-hand side is already factored. All we have to do is set each factor equal to 0. N plus 9 is 0 and n minus 2 is 0. And so the two solutions are n equals -9 and n equals +2. Okay, the next equation, 5x squared minus 35x equals 0. The right-hand side is 0. We want one side to be 0 when we solve by factoring. And then we factor the left-hand side. So what are the factors of the left-hand side? Times
5x times x minus 7.
Yeah, 5x times x minus 7. Yeah, the greatest common factor is 5x, and then when we factor 5x out, the other factor is x minus 7. All right, what are the solutions?
X equals 0 and then x equals 7.
Yep. Yeah, so what we can do is we can set each of the factors equal to 0. 5x equals 0. And x minus 7 equals 0. If 5 times x is 0, we can divide both sides by 5. 5x divided by 5 is x. 0 divided by 5 is 0. And then the other one adds 7. So the two solutions are x equals 0 and x equals 7. Okay, the next equation, x squared minus 9x equals -18. To start with, we want one side to be 0. So we can add 18 to both sides, and we get x squared minus 9x plus 18 equals 0. And then factor x squared minus 9x plus 18. Okay, if you're online, go ahead and type in the factors, see what you get. Or type in the equation you get after factoring. Okay, so what's the equation after factoring the left-hand side? I'll do half of it. The right-hand side is 0. What's the left-hand side?
X squared minus 3x minus 6x plus 18.
Okay, yeah, that's the first step of the AC method, and then yeah, we might as well go through the process of the AC method. So 1 times 18 is 18. Two integers that have a product of positive 18 and a sum of negative 9, or negative 6 and negative 3. Okay, then transform the trinomial into a quadronomial. So there's 2 ways to do it. One way is to write x squared minus 6x minus 3x plus 18. And then factor by grouping out of the first 2 terms. X squared minus 6x, the greatest common factor is x. And then the binomial is x minus 6. Okay, the next step in the process, it's important to remember the middle operator in the quadronomial is subtraction. So we want to bring down subtraction. And then that reminds us that out of the third and fourth terms, we're going to factor out the negative of the greatest common factor. The greatest common factor is 3. So when we factor out negative 3, the binomial is x minus 6. Okay, then we get x minus 6 times x minus 3 equals 0. And we have one side 0 and the left-hand side factored, so set each factor equal to 0. X minus 6 is 0, and x minus 3 is 0. Then we get 2 solutions, x equals positive 6 and x equals positive 3. Okay, the next one, y to the second minus 17, or y to the second minus 14y plus 49 equals 0. Solve this by factoring. One side is already 0, so we factor the trinomial. The greatest common factor of the 3 terms is 1. So if you know the factorization, go ahead and type that in. Hold on. Okay. Nobody online wants to answer.
Is it y minus 7 squared?
Yep. When we fact, this is a perfect square trinomial. So you can write it as y minus 7 squared. Or if you write it y minus 7 times y minus 7, that's also permissible. This equation has one solution with multiplicity 2. So y equals 7 is the only solution. Okay, let's move on to the next page. So 25x squared equals 16. Solve that equation. Hey, there's a question on YouTube. Well, you can always check your factoring by multiplying. So if we're going to solve by factoring, we want one side to be 0. So we can subtract 16 from both sides. Notice that both of the terms are perfect squares. 25x to the second is the term 5x squared, and 16 is 4 squared. So this is a difference of two squares. Just to remind you, if you have a difference of two squares, a squared minus b squared, one factor is a minus b and the other one is a plus b. So if you're ever in doubt, if you're uncertain about whether a minus b times a plus b is the correct factorization, you can just multiply a minus b times a plus b. So if you multiply a minus b times a plus b, you get a times a is a to the second, and then plus a times b, and then minus b times a, which is the same as minus a times b, and then minus b squared. And when you combine like terms, the two middle terms add up to 0, so you're just left with a squared minus b squared. I'm not sure if I answered your question online, but anyway, this is a difference of two squares. One of the factors is 5x minus 4. The other factor is 5x plus 4. Okay, then set each factor equal to 0. One factor is 5x minus 4. Set that equal to 0. We'll go ahead and solve it. Add 4 to both sides, so we get 5x equals 4. And then divide both sides by 5, we get x equals 4/5. And then the other factor Set 5x plus 4 equal to 0. Subtract 4 from both sides. 5x equals negative 4. And then divide both sides by 5. X equals negative 4/5. Okay, so the two solutions are x equals 4/5 and x equals negative 4/5. Okay, the next one, 14y squared minus 77y equals negative 35. If we solve by factoring, we want one side to be 0. So we'll add 35 to both sides. And we get 14y to the second minus 77y plus 35 equals 0. The greatest common factor of all three terms is 7. Since we're solving an equation, remember an equation always has an equal sign, then when we're solving an equation, we are permitted to divide every term on both sides by the same non-zero number. Since the greatest common factor is 7, we can get rid of a bunch of the clutter that's in the way if we divide every term on both sides by 7. So that will pare the numbers down so that the arithmetic will be easier. Okay, so divide every term on both sides by 7, we get 2y to the second minus 11y plus 5. 0 divided by 7 is 0. So in my opinion, it looks easier to solve 2y to the second minus 11y plus 5 equals 0 than the other one. But the solutions to the two equations are exactly the same. All we did was we divided both sides by a non-zero number. Okay, so factor the left-hand side. We can use the AC method. 2 times 5 is 10. So 2 times 5 is 10. Find two integers whose product is 10 and whose sum is negative 11. Those two integers are negative 1 and negative 10. Negative 1 times negative 10 is positive 10, and negative 1 plus negative 10 is negative 11. Okay, so we'll transform this trinomial into a quadronomial. Replace the minus 11y with minus 1y minus 10y. And then factor by grouping. Out of the first two terms, we factor out y. And the binomial that stays is 2y minus 1. Then bring down the middle operator of subtraction. The greatest common factor of the third and fourth terms is 5, but we're going to factor out negative 5. And the binomial is 2y minus 1. And then finally, the complete factorization is 2y minus 1 times y minus 5 equals 0. Okay, set each factor equal to 0. One factor is 2y minus 1, so 2y minus 1 equals 0. Add 1, 2y equals 1, and then divide both sides by 2. We get y equals 1/2. The other factor is y minus 5. Set that equal to 0, and then add 5 to both sides. Y equals 5 is the second solution. Okay, so the two solutions are y equals 1/2 and y equals 5. The next equation, 4a to the second plus 7a equals -3. Okay, we're going to solve by factoring, so we want one side to be 0. So we'll add 3 to both sides. We get 4a to the second plus 7a plus 3 equals 0. The greatest common factor is 1, so we can use the AC method. So we multiply 4 times 3 to get 12. Two integers that have a product of 12 and a sum of 7. Well, we already have those integers, 4 and 3. So right off the bat, 4 and 3. The next step, transform the trinomial into a quadronomial. We'll write 4a to the second plus 4a plus 3a plus 3 equals 0. Then factor by grouping. Out of the first two terms, factor out 4a. The binomial is a plus 1. The middle operator of addition, bring down addition. The greatest common factor of the third and fourth terms is 3, so we factor out 3. 3 times a plus 1. And then finally, the two factors are a plus 1 times 4a plus 3. 4a okay, a plus 1 times 4a plus 3 equals 0. When we set a plus 1 equal to 0, since I'm running out of space, a plus 1 is 0, we subtract 1, we get a equals -1 for one of the solutions. Then when we set 4a plus 3 equal to 0, we subtract 3 and then divide by 4, and we get a equals -3/4 for the second solution. Okay, the next equation, m to the third minus 2m to the second equals -m. In order to factor, or in order to solve by factoring, we want to add m to both sides so that the right-hand side is 0. And we'll get m to the third minus 2m to the second plus m equals 0. Then we factor out the greatest common factor. The greatest common factor is m. So factor m out, and then we get m to the second minus 2m plus 1 equals 0. We want to, if it's possible to factor m to the second minus 2m plus 1, we want to factor it. What did you come up with for the factors of m to the second minus 2m plus 1?
M to the second minus 1m minus 1m plus 1.
Okay, and then factor by grouping. Yeah, if you use the AC method on m squared minus 2m plus 1, 1 times 1 is 1. Two integers that have a product of 1 and a sum of negative 2 are negative 1 and negative 1. So this is a perfect square trinomial. One factor is m minus 1, the other one is m minus 1. Okay, so the solutions to this equation, what are the solutions?
1 and 0.
Yeah, 1 and 0. One of the factors is m, so set m equal to 0. We have identical factors. So there are just two solutions, m equals 0 and m equals 1. M equals 1 is a solution with multiplicity 2 because there are two identical factors, but we only list the solution once. Okay, let's look at the word problems. The product of two consecutive odd integers is 255. Find the integers. Okay, so we can represent two consecutive odd integers. One way to do it is to say that x and x plus 2 represent two consecutive odd integers. You could also write x and x minus 2 if you prefer, but either way, you'll get the same results. The product is x times x plus 2 is equal to 255. We get a polynomial equation. If we multiply x times x plus 2, we get x squared plus 2x equals 255. And then we'll solve by factoring, so we'll subtract 255 from both sides. X squared plus 2x minus 255 equals 0. Now we'll factor the left-hand side. The greatest common factor is 1. So we use the AC method. 1 times negative 255 is negative 255. Okay, so find two integers whose product is negative 255 and add up to positive 2. So did you find those integers? Well, if the product is negative, one must be positive and one must be negative. If they add up to a positive number, the one with the largest absolute value must be positive. Yeah, I don't have a lot of space on that paper, so over here I'm going to On another piece of paper, I'll use our systematic search. So -1 times 255. -2 is not a factor. -3 is. -3 times 85. -4 is not a factor, but -5 is. -5 times 51. -6, -7, -8, -9, -10. So it looks like -17 times +15. Yep, those two numbers do it. Wait. That's not right.
Be -2.
It's what?
That would have been -2.
Can't hear you.
That would have come to -2, right?
Yeah, that can't be right. Oh, so, sorry. -15 and +17 are the integers we want. Yeah, they got them online for me already. So -15 and +17. Okay, so we'll go ahead and x squared, replace the plus 2x with minus 15x plus 17x. Okay, then factor by grouping out of the first two terms, factor out x, and then x minus 15. Bring down plus, and then out of 17x minus 255, we factor out 17 and x minus 15. The two factors are x minus 15 and x plus 17. When you set each of those equal to 0 and solve for x, we get x equals 15 and x equals -17. Those are the two solutions. We have two pairs of solutions, though. We're trying to find consecutive odd integers. So if x equals 15 is one solution, then x plus 2 is x equals 17. The other pair of solutions, if x equals -17 is one of the integers, the other one is -17 plus 2, or -15. So we have two sets of solutions. I'm really fouling this one up. This should be x plus 2 is 17. The other one is x plus 2 is -15. Okay, maybe I'll do better on the next one. The product of two consecutive even integers is 224. So if it's two consecutive even integers, we can use the same representation, x and x plus 2. And then multiply x times x plus 2 and set it equal to 224. And then x squared plus 2x equals 224. To solve by factoring, we subtract 224 from both sides, and we get x squared plus 2x minus 224 equals 0. The greatest common factor is 1, so we apply the AC method again. Okay, so 1 times negative 224 is negative 224. Find two integers that have a product of negative 224 and a sum of positive 2. So one must be positive, one must be negative. So we pick the one with the largest absolute value to be positive. So we'll do our systematic search, negative 1 times 224, 224, and then negative 2 times 112. Negative 3 is not a factor, but negative 4 times 56. Negative 5 is not a factor. Negative 6 is not a factor, but negative 7. Negative 7 times 32. Negative 8 times 28. Negative 9 is not a factor. Negative 10 is not a factor. Negative 11 is not. Negative 12 is not. Negative 13 is not. Negative 14 times positive 16. Yeah, negative 14 and positive 16. Okay, so we'll write x to the second minus 14x plus 16x minus 224 equals 0. Then factor by grouping out of the first two terms, factor out x. So we get x times x minus 14. Bring down the middle operator of addition and factor out 16. And we get x minus 14. The two binomial factors are x minus 14 and x plus 16. So we get two sets of solutions again, corresponding to x minus 14. One of the consecutive numbers is 14, and then x plus 2 is positive 16. That's one pair of consecutive integers that have a product of 224, consecutive even integers. And then the other one, x equals negative 16, and then x plus 2 is negative 14. That's the second pair of consecutive even integers. Okay, part C. The product of two consecutive integers is 240. Find the integers. If it's two consecutive integers, then x and x plus 1 represent consecutive integers. And then the product is 240. So x times x plus 1 is 240. Or x squared plus x equals 240. Then subtract 240 from both sides. X squared plus x minus 240 equals 0. Okay, I'll leave the rest of this for you to work on so that we can look at some of the other problems. But you can go about finding the solutions to this in a same sort of way that we did on the previous two examples. But let's look on the next page. Part D, the area of a rectangle is 28 square feet. The length is 5 feet less than 3 times the width. Find the length and the width of the rectangle. Okay, if we assign a single variable for the width, if we say that the width is x feet, the length is described in terms of the width. We're told that the length is 5 feet less than 3 times the width. So if the width is x feet, 5 feet less than 3 times x can be represented by 3x minus 5. So that looks like it works. 5 less than 3 times x. And then the area of the rectangle is length times width. So 3x minus 5 times x equals 28. Multiply the 3x minus 5 times x, so we get 3x squared minus 5x equals 28. We'll solve by factoring, but first we subtract 28 from both sides, and we get 3x squared minus 5x minus 28 equals 0. The greatest common factor is 1, so we apply the AC method. 3 times negative 28 is negative 84. We want to find two integers that have a product of negative 84 and a sum of negative 5. So the one with the largest absolute value will be negative. So if we start at 1 times negative 84, 2 times negative 42, we already have positive 3 times negative 28, then positive 4 times negative 21. 5 is not a factor, but 6 is a factor. 6 times negative 14. And then 7 times negative 12. And those do add up to negative 5, so 7 and negative 12. And so we transform the trinomial to a quadronomial. I'll write it as 3x squared minus 12x plus 7x minus 28 equals 0. Out of the first two terms, the greatest common factor is 3x. The binomial is x minus 4. The middle operator of addition, and then out of 7x minus 28, the greatest common factor is 7, and then x minus 4. We get two factors, 3x plus 7 and x minus 4. This equation has two solutions, but one of the solutions is negative. In the context of this problem, we just want the positive solution. So the positive solution for x is positive 4. So that means the width is 4 feet And then the length is 3 times 4 minus 5, or 12 minus 5, or 7. Okay, so there's not a lot of room here, but you can say that the width is 4 feet. And the length is 7 feet. Okay, the next one, a right triangle has a hypotenuse of 10 feet. The length of one leg of the right triangle is 2 feet longer than the other leg. Find the length of each of the 2 legs. Okay, we're given that the hypotenuse is just 10 feet. And then when we compare the legs, one of the legs is 2 feet longer than the other. So I'll label this side x, and the other one is 2 feet longer, so it's x plus 2. Then we apply the Pythagorean theorem to the right triangle. We square the hypotenuse, 10 squared, that's equal to the sum of the squares of the 2 legs. So we square x to get x squared, and we also square x plus 2. So we're going to get 100 equals x squared. When we square x plus 2, we get x squared plus 4x plus 4. And then 100 equals 2x squared plus 4x plus 4. We'll subtract 100 from both sides. So we get 0 equals 2x squared plus 4x minus 96. Since the greatest common factor is positive 2, we can divide every term on both sides by positive 2. And I'll write it as x squared plus 2x minus 48 equals 0. Okay, it wouldn't take too long to find the 2 factors are x plus 8 and x minus 6. The 2 solutions, one is negative 8, the other one is positive 6. But in this problem, we only want the positive solution, positive 6. So the short leg is x equals 6 feet. And the long leg is 2 feet longer, 6 plus 2, or 8 feet. Okay, we have a little over 2 minutes left. Part F, I'll leave that for you to work on. It's similar to Part D, but let's take a look at Part G. From the top of a building that is 80 feet above the ground, a projectile was launched upwards, and the height h in feet of the projectile above the ground t seconds after being thrown is modeled by this equation. H equals negative 16 t to the second plus 64 t plus 80. So in part 1, find the number of seconds it takes for the projectile to reach 144 feet. So what that means is, for part 1, replace h with 144, so you get 144 equals negative 16 t to the second plus 64 t plus 80, and then solve this equation for t. So we want one side to be 0, So let's subtract 144 from both sides. We'll get 0 equals negative 16t to the second plus 64t. And then 80 minus 144 is negative 64. You can get rid of a bunch of the clutter that's in the way if you divide every term on both sides by negative 16. So 0 divided by negative 16 is 0. And then when we divide every term on the right-hand side by negative 16, we'll get t to the second minus 4t plus 4. And this is a perfect square trinomial. The two factors are t minus 2 and t minus 2. So t equals 2 seconds is how long it takes for the projectile to reach 144 feet. Okay, I'll just set up the part 2. Find the number of seconds it takes for the ball to hit the ground. So this time replace h with 0. And then we have 0 equals negative 16t to the second plus 64t plus 80. And then on this one, you can divide both sides by negative 16. And then you can easily solve the equation after that by factoring. Okay, we're out of time. Go ahead and sign in for attendance.
Thank you.